Hey, hello, welcome to SOH, the best office hours, because you are part of it. Now, Calculus AB 2024, problem number 5, getting closer to problem number 6, I know, soon we'll be done. What is this problem about? First, we are going to cover what's about, the techniques that you need to know, and then I will go question by question. So maybe in the next couple of minutes you are done. You can move on to the next 3 million of problems minus 1, and let me know how it goes. If you get a 5, call me back, okay? So what do we have here? We have a curve. We are not going to look at this curve in very much detail, but just to let you know, this looks like a circle. It's an ellipse, okay? It's an ellipse. It's not centered at 0, 0. Why is that? X squared plus y squared, and there is this cross term here. We're not going to deal with that, but it's an ellipse. Otherwise, it couldn't work, this problem as it's written. Anyway, they say that it can be shown that this derivative equals to that. Indeed, you could derive that, and I'm going to show you that later, but let's go to the point now. There is a point, yes, to this point precisely, on the curve near 2, 4 with x coordinate 3. Okay, nice. Use the line tangent at this point to approximate the value. Okay, so how are we going to do that? Well, you're going to use this expression that is going to be approximately the value here plus the slope, the derivative at the value of this. So you have the point 2, 4, and then the derivative. You need to compute the derivative here, but you have the expression here, right? So you can substitute and get it, and then you will get the value. That's the way. Is the horizontal line here tangent to the curve? Well, this is a bit tricky and important. It looks like very simple, right? Use horizontal line, and therefore the derivative here must be 0. End of the story. So B is basically, can I solve this problem? And it's too easy, right? Because you get x equals to 0. But that's not the end of the story. Because you have x equal to 0 and y equal to 1. Does this point belong here to this curve? If it does, then you're done. And yes, that line is tangent. If not, it's not. So we'll have to substitute and see what happens. So be careful with that, okay? The curve intersects the point at this point, okay? Now here you have x and y. You have everything. Now, is this line tangent vertical? Well, vertical is that the denominator of this is 0. But for y equal to 0, that's equal to 3. So, you know, the denominator for y equal to 0, that goes 3. It's different from 0, so no, it's not vertical. End of the story. But we will try to give a little bit more of justification, because of course you don't want to say, well, maybe I say a little bit less and I get less than a 5. We don't want that to happen, right? Once you're done, yes, you can look cool like me because I don't need to get a 5. I already got it a long time ago. But once you're there, you really want it. So we are more formal, right? So we'll do that later. Then for time, but this is correct. And then the last question, oh my goodness. Now we have another curve here. This is not an ellipse. And then we have a point x and y. And oh yeah, decreasing at the rate. That's very important. You see here, we have some units here. That's very tricky. Don't forget to use the units at the end of the answer, okay? So that's usually implicit derivative. So what you have to do here is implicit derivative, and yes, and solve it, okay? Using all that information. So maybe with this you are done. You can practice on your own if you want to look at it later, or just go to the problem that you like. Now for the next one, for those who stay, let's dive into it. So question number A, if it's okay, let's approximate this function. So this is nice. You know, there is this very general result that if the function is differentiable, then near a point you can always approximate that function by this expression, and then plus more, but we ignore this, okay? We ignore these terms. If we don't ignore them, it's because we want to go to a higher precision, but they just say the line tangent, so that's enough. We have a line here, right? We have an x, that's a line. So, well, let's substitute. We have here y, that would be y naught plus the derivative at that point, and then x minus x naught. Do we have everything? Well, let's see. Y naught is 4, right? What else? X naught is 2, and then the derivative at this point, well, it's not, it depends on both coordinates, that's fine, but it's that expression, minus 2 times 4, no, minus 2 times 2, right? Thank you. 3 plus 4 times 4. So it's going to be minus 4 times divided by 19. It's not a very nice expression, but it's okay. It's correct, minus 4 divided by 19. And then if we plug everything here, we have that this curve is approximately the number 4 minus 4 divided by 19, x minus 2. So for the case of x equal to 3, because it's the one that they want, it's going to be 4 minus 4, a little bit of patience, but we are almost there. So 4 minus 4 is a lot of writing, right? And then 19 19 times 4, 76, minus 4, 72. 72, this is a prime number, we cannot simplify it, that's it, okay? Cool. Sometimes they could ask us, it would be interesting, if this is an overestimate or an underestimate. Look for that 2023, I think, there's a good example. You have to go with the second derivative. I was also saying, it's optional, that you can prove this thing here. How? With the implicit derivative that you need to do in the last question, so it might be interesting. So you do 2x plus 3y prime plus 4y prime equals 0. Then you use everything that has y primes on one side. So let's say like this, right? And then you isolate it, and look at that, miracle of miracles. The guys who wrote the AP problem weren't wrong. Okay, good. So should we give them a 5? I'm not sure yet. Huh? But anyway, they passed. So let's go for the next question, question B. Is the line horizontal? This is interesting, in fact, because this looks like very simple. So first of all, say, wow, it's horizontal. I'm so lucky. This is just that. You look at this equation here, and what do you have? Just this. So x equal to 0. Done. No. And done. And done. Not done. And done. Okay? Why? Because we have found a point where the tangent has 0. Zero slope. So indeed it's horizontal, but not the height. Which height? Well, these guys say y equal to 1, but we are living in this curve. So what's the height that corresponds to x equal to 0? Well, let's see. So you can substitute 0, you would have this, and then try to solve it, right? But the point is like, that's a long way. They want this to be true. Okay, let's see. 0 squared plus 3 times 1 plus 1 squared. That's basically 3 plus 2, 5. This I can do it. So, and 5 is different from 48. I can also do that. So, no. Okay? So, y equal to 1 is not tangent to the curve. It's not tangent to the curve. It will be at another height. So, if you have that ellipse that we were talking before, maybe this is the curve that they are giving us. So there are other two lines where actually yes, but not there. Okay, so let's move on. What happens here if it's vertical? Well, that's interesting. Usually vertical means that you want this denominator to be 0, and you can say that in the official solution. Basically, if the denominator of the y prime is 0, then the tangent line is vertical. However, this derivative, and this is a, look, we have x equal to 0, no, what I'm saying, x equal to square root of 48, right, and y equal to 0. However, here, well, this is not going to, the denominator is not going to be 0. Basically, you have all this. You don't really need to compute all this. It's basically saying that the denominator is not 0, but so, since this is different from 0, then no, it's not vertical. It's not vertical. And that's it. End of the story. Let's move on. So for the last one, what happens here? Wow, we have another particle moving. Let's be careful with this problem. Sometimes, you have a speed, and so it's a different curve, right? So, and then the speed and velocity is different and these kind of things. But let's see. We have a point 4, 2. What else? The y coordinate is decreasing is a minus, right? 2 units per second. What is the question? The x coordinate. Oh yeah. So for this we have to do the implicit derivatives. Let's choose a different color just to change a little bit. So, but be careful. It's not this curve, right? It's that one. So you have this curve here, and you want to compute. You want to derive. If we know dy divided by dt is minus 2 units per second, or minus 2 units per second. If we know that, can we know how much is dx dt? Okay, so for that we are going to do implicit derivatives, and by that I mean the following: 3 times y squared, that derivative of this with respect to dt, plus, very similar to implicit derivatives, 2, but here is not 1 because it is with respect to time. So dx dt, this is not 1, okay? It's not 1. Okay, that x prime equals to 1, but that's something else. That's something different, okay? Don't get confused with that. So let's continue. multiplied by what? By y plus 2x dy dt equals to 0. Now here you have to be patient and be very careful. So how much is y? Y is 2. How much is dy dt? Dy dt is minus 2. Dx dt is what we're looking for. How much is y? We said that was 2. And how much is x? X equals 4, right? It's here. So now let's be careful with that. That's 3. That's also, easy to get it wrong. Any little mistake here. And these problems are hard to really know if it's correct or not. Plus 2 times 2 is 4 times what we are looking for, dx dt. And then what else? Plus 8 times, oh yeah, that was minus 2, so 8 times minus 16, right? Equal to 0. So this is 3 times 4, 12, minus 24, minus 16, minus 40. So we get that 4 times what we are looking for equals 40. So what we are looking for. But again, it's like, can I know that this is and units per second? Before I talk anymore, look at this. Units per second. This is super important, okay? This part here, units per second, is super important. Okay, super important. Now, what about to try to check whether this is right or not? Well, there is a way that may help. So let's use another piece of paper. It's the end, so you can leave if you want, but it's always good to be able to check. So you have that dx divided by dt should be equal to 10. That's what we get, 10 over 10. And dy divided by dt equals to minus 2. We don't really want to be negative, okay? Now, from here, you could derive that dy divided by dx, so y prime, right, would be minus 2 divided by 10, which is minus 1/5 for you. The tricky point is that this derivative is not this derivative, because this is a different function. It's about this derivative, but if you're good, as I know you are, because that's why you're here, then you can compute the implicit derivative of this thingy. And let's see, let's practice. So 3y squared y prime plus 2 now is 1, because we are taking the y prime, so x prime equals to 1, plus 2xy prime equals to 0, right? So we want to isolate y prime, so 3y squared plus 2x, all this is y prime, and this goes to the other side. So what we have is that y prime equals minus 2y divided by all this mess. But now let's substitute what? Let's remember x4 and y2. Let's see. Let me remember. Yes. What about that? Good memory. You have better than I. So minus 2 times 2 divided by 3, 2 to the blah, 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 minus 4, 3 times 4, 12, plus 8, minus 2 divided by 20, no, minus 4 divided by 20. 1 second, I was so excited already simplifying mentally, it's like, yes, we got it, and I was so excited. But minus 4 divided by 20, which is minus 1/5, which is this. So not only a plus, man, a plus plus, okay? That's our baseline, A plus plus. Okay, see you in the next one. Don't miss it. Bye.